Inductively coupled plasma atomic emission spectroscopy. Atomic emission spectroscopy is the reverse of atomic absorption spectroscopy. In this technique, wavelengths of light are studied which are emitted by atoms or molecules during their transition from an excited state to a lower energy state. Atomic emission spectroscopy fundamentally consists of three general steps: breaking of sample into a constitutional atoms, atomization, excitation of atoms, emission of electron falls back into their original orbit. Of this, the first step, atomization, is used in atomic absorption spectra as well. As atomization should be produced with a minimum ionization of elements to be analyzed. It can be done by a number of methods. As example, by heating the sample to a high degree. ICP-AES utilize plasma as the atomization and excitation source. Plasma is a state of matter similar to gas in which particles are ionized. Plasma can be produced by supplying energy to matter. The sun, lighting, and the aurora borealis are examples of plasma found in nature. An inductively coupled plasma is plasma produced by supplying energy in the form of electric current produced by electromagnetic induction. Creation of ICP argon gas is typically used to create plasma by electromicroscope induction. If temperature ranges from 4000 to 8000 K, use of this plasma as an atomization and excitation source. Sample is introduced inside the plasma. Its molecule immediately collided with the electrons and charged ions in the plasma. Sample is broken down into respective atoms. Electrons in individual atoms get energy from plasma and rise to a higher level excitation. As they return to their original position, they emit a radiation. In the process, they give off radiation at their characteristic wavelength of the element induced. This radiation is studied to reveal the composition of sample. Capabilities: metals can detect numerous simultaneously based on their emission lines. Non-metal, phosphorus, sulfur, halogen have strong emission lines in their vacuum. Ultraviolet, UVV, ultraviolet ranges from 100 to 200 nanometers, so called. Because it persists in vacuum, it's strongly absorbed by an air. Earlier ICP-AES, inductively coupled plasma atomic absorption spectroscopy instrument did not have UVV capabilities, but now such instruments are available and detection of non-metal is also possible. Thank you.